Hi everyone, welcome to my presentation on modulation technique. Today, I will going to talk you through the essential modulation technique used in communication system, focusing on both analog and digital modulation. I will explain how they works, show you the circuit behind them, and make some comparison along the way. By the end of this video, you should have a good understanding of how modulation plays a crucial role in transmission information. Let's dive through in. Now I will do an introduction about analog and digital. So what is analog? The analog modulation is a continuous signal is modifying to encode information. There are three types of analog modulation, which is AM, FM, and PM. Next is digital. The digital modulation involves encoding binary data into a carrier signal, which can be transmitted more efficiently over long distance. The common type of digital modulation are PSK, ASK, and FSK. In my presentation, I will present about AM and FM. This is the AM modulator and demodulator, which is balance modulator and envelope modulator. For AM modulator, the primary purpose is to superimpose a low-frequency information signal onto a high-frequency carrier wave by verifying the amplitude of the carrier wave, allowing the information signal to be transmitted over long distance through radio wave. Next is the envelope detector. The envelope detector is designed to extract the amplitude variation of a modulation signal, essentially provide a signal that represents the changing initial of the original signal. This is the two FM modulation and demodulation, which is VCO, voltage control oscillator, and PLL, phase lock loop. For VCO modulator, its function is to change the frequency of a VCO in response to an input voltage. Next is the PLL demodulator. A phase lock loop demodulator is to track the frequency and phase of an incoming signal to create a demodulator signal. Next is the digital modulation, which is ASK and PSK. ASK stands for amplitude shift keying, where data is represented by changing the amplitude of a carrier wave, while PSK stands for phase shift keying, where data is represented by changing the phase of the carrier wave. Next, here are the ASK modulator and demodulator, which is diode switching modulator and envelope detector. For diode switching modulator, it uses a diode as a switch to generate an amplitude modulated signal, essentially turning the carrier's wave on and off at the rate of the modulating signal. Next is the envelope detector. The function of this is same as the previous slide. Next is PSK modulator and demodulator. For VPSK modulator, it is a mathematical operation that takes a binary data stream 0 and 1 and transfer into a modulated carrier wave by changing the phase of the carrier signal based on the data bits. The Fourier detector, its function is to measure the amplitude and phase of a sine signal by mixing it with a local oscillator signal. Lastly, this is the comparison for analog modulation and digital modulation. For signal type, analog modulation is a continuous signal. For digital modulation, it is a discrete signal. Next is the noise resistance. For analog modulation, it less to noise susceptible to signal degradation. For digital modulation, high noise resistance data recovery is more accurate. Next is the bandwidth efficiency. For analog modulation, it requires more bandwidth due to continuous variation. For digital modulation, generally more bandwidth efficient, especially with higher order schematic like QPSK. Next is the circuit complexity. For analog modulation, it is more simple modulate and demodulation. For digital modulation, it has more complex circuit, especially for demodulation. Lastly, for application. For analog modulation, it used in AM/FM radio, analog TV, and voice communities. Next is digital modulation. In use in Wi-Fi, 4G or 5G network, and satellite communication. And that's all for me. Thank you.